Okay, so let's finish it off in this one. So with reference to the photoelectric effect, state is what is meant by threshold frequency. So threshold frequency, क्या कहते हैं?
It is the minimum frequency required before we can observe any electrons, emitted electrons.
So yeah,
any emission of electrons.
It is the minimum frequency of electromagnetic radiation required
before any emitted electrons can be observed.
To emit any electrons, or for the photoelectric effect to happen. Another way you can do this, that it is the minimum frequency where either, so to clarify one thing, at the threshold frequency, photoelectric effect does happen, but it only emits electrons from the surface of the metal. Because if you have more than that, then stuff like the work function comes into place. Then you have to take the electron to the surface and then you emit it. So F0 is the minimum frequency required to emit any electron from surface. लिख सकते हैं आप. So yeah, because if it's within the metal, then you need more frequency than that, ताकि the concept of work function links in and all that. You can bring it to the surface and then it emits. And you have to sketch this. So if you remember the formula, E is equals to HF. H is constant. We don't really care that much about that. F could be called C upon lambda. We're kind of linking with V is equals to F lambda C because that's speed of light. So the idea here is that
मुझे आवाज नहीं आ रही किसी पंखे की.
Okay. So yeah, I think we're good now. Yeah, so what I'm trying to show here is that H and C is the speed of electromagnetic radiation, right? So like that's constant. So basically H can be either आपने constant ले लिया, and this is 1 upon lambda. So we can say जो energy है, that is proportional to 1 over lambda. So it should be a straight line. The thing to keep in mind is that it won't pass through the origin, because here this is kinetic energy, and if you remember ये जो था energy, some of it went into the work function, which was required to pull it out of to the surface of put the electrons to the surface of the metal, and then the rest was your HF. So this basically would be your energy required to bring the electron to the surface, the work function.
The HF ऊपर जाओ, गलत बना है.
Sorry?
गलत बना है. The HF is actually the E we want, because E जो है वो kinetic energy of electrons. E जो तुमने E लिखा है, जो actual E है वो हमने provide किया है, उसमें से कुछ work function वाला है और कुछ KE वाला है. हमें KE वाले का ग्राफ बनाना है. समझ आई बात?
Okay, so we only have to draw KE wala.
KE wala is HF की जगह तुम E max लिख दो. KE लिख दो बल्कि सही है. Which is y axis. HF की जगह equation में.
I'm sorry, I towards the क्या बोल रहे हो यार, अभी शोर इतना क्यों आ रहा है? हाँ.
Hello. शोर मुझे भी आ रहा है, लेकिन this is not from my mind.
Okay, very good. Yeah, so you were saying that this is kinetic energy, and so are you saying something like this?
Yeah.
Okay, so my bad.
So the thing is, you need a wavelength चाहिए, फिर energy होगी. शुरू में energy नहीं होगी.
Yeah. So I didn't get देखा कि ये kinetic energy. So Ali, there's too much noise coming from your end. So idea here is you need some amount of frequency, basically C upon lambda, to bring the electrons to the surface, and only after that do you get kinetic energy. So state an equation relating the gradient of the graph shown on figure 11.1 to the Planck constant H. to HF, which you can basically write as E is equals to H C 1 upon lambda. सही है. तो gradient क्या होगा? Gradient would be HC, right? Explain why for any particular wavelength of electromagnetic radiation, most of the electrons are emitted with kinetic energies less than the maximum value E max. Because क्या कहते हैं, आपकी उतनी frequency होती नहीं है, like lambda is not normally that small.
नहीं, इसका I think basic answer है.
Okay, so idea here is for a particular wavelength. So wavelength को vary नहीं कर रहे, but we're saying most kinetic energies are less than the maximum value. Idea here is, so E max would happen when electron is on surface. अगर surface पे है तो फिर all of the energy is just used in providing kinetic energy. There is no work function involved. However, that doesn't happen for most things, because most things, and some amount of energy, in most cases for most electrons, is used to bring the electron to the surface. Ali, I think तुम्हारी आवाज थोड़ी सी कट गई. Light of a particular wavelength is incident on a metal surface and gives rise to photoelectric current. So yeah, the wavelength is reduced, which is basically also like saying that frequency is increased, which is like also like saying that HF for आपकी energy would increase. The intensity of the light is kept constant. State and explain the effect, if any, on the photoelectric current. Intensity का क्या होता था? Intensity was power upon area.
इसकी जरूरत नहीं है ना. बात ये है कि photoelectric current does not depend on intensity. मतलब the number of sorry, हाँ सही तो है. ये एक लंबा चीज है. E is equal to HF. हाँ सही से करो.
सही है. So if you have this, however, we're saying that the wavelength is decreased, which means the
Okay, फर्क ये है असल में कि वो जो E is equal to HF है, that is energy per photon, and E is equal to E upon T है, that is the E of all the photons.
So there will be fewer photons then, because
yeah.
So since intensity is constant, दिया गया intensity is constant, तो मतलब the overall energy is constant. So the overall energy is constant. However, the idea here is, since lambda has decreased, which is another way of saying frequency has increased, the energy E here, which is basically energy of a photon, that has increased. So for the same overall energy, individual photons have more energy. So you have less photons.
So less current
per unit time, obviously. If you have less photons, then you would have less electrons emitted per unit time. Per unit time, so current जो आपका है, that goes down. And some people yeah,
thing is, when you're writing, it's like hanging and then
okay. Some people have this confusion. They're like, nahin, lekin photon ki energy to बढ़ रही है, right? So shouldn't more electrons be emitted? The photon ki energy, if it's greater, then the electrons that are being emitted, उनकी बस kinetic energy बढ़ जाएगी. It won't really help emit more electrons. It जितना वो करना है उतना ही करेगा, and उसकी kinetic energy बढ़ा देगा.
Yeah, that is the principle of the photoelectric effect.
Yeah. So in an X-ray tube, the hardness of an X-ray beam may be controlled. So state what is meant by hardness of a beam. So the degree of its penetrating power. State how the hardness of the beam may be decreased. Anode potential say, I believe. Am I right?
Yeah, I think it decrease the potential difference.
Yeah, I believe anode potential आप कम कर दो. So that should work. This is decrease accelerating voltage or decrease voltage between cathode and
Potential
anode.
difference will decrease
Yeah.
the potential difference.
So let's a better way to write it
सही
is
है ना?
PD. Anode even if you just vary the anode potential, उससे ये potential difference मतलब कम हो ही जाएगा. But चलो a better way to phrase it. And the reason, what's the logic for this? Is there a way we can explain the logic?
वेलोसिटी है ना, वेलोसिटी क्या कहते हैं, पार्टिकल्स की वेलोसिटी कम होगी तो उसी तरह HF फ्रीक्वेंसी कम होगी, फ्रीक्वेंसी कम होगी तो हार्डनेस कम होगी.
Okay. So because higher frequency radiation is normally more penetrating, right? Like stuff like gamma and stuff like that.
Yeah.
Okay. So state one advantage and one disadvantage of producing a CT scan image of a person rather than a standard X-ray image. So advantage, you can have a 3D image.
3D image है ना, 3D image can be seen from multiple angles.
3D image can be seen from multiple angles.
Disadvantage, there is a lot more radiation the person is exposed to.
Correct. Lot more radiation
Exposure.
Yeah, which is not too cool because this is harmful. So yeah, let's see, we get to the last.
वो देख लो मैगी स्कीम.
Because in these questions, image gives depth. Image is 3D, which is good enough. Disadvantage: greater exposure, more risk to health, more expensive.
More expensive. हाँ, ये expense हमेशा अच्छा होता है. Advantage, disadvantage.
Person must remain stationary. यार उसे पता
हाँ ना, जब तक वो पूरा 3D image complete ना हो जाए.
मतलब यार, how sad for the poor guy. Like 2 मिनट खड़ा हो जाए शराफत से, रहेगी नखरे बहुत देखो. Like चलो, beryllium 7 is produced in the upper atmosphere and then sinks down onto the Earth's surface. Nuclei of beryllium 7 decay with half-life of 53.3 days to form stable nuclei. The activity of a sample of beryllium 7 is this. This is milli, right?
हाँ मिली है ना.
Yeah. M लगा. Show that the decay constant.
Milli-becquerel.
Yeah. So activity आपका क्या होता था? Activity को अगर हमने link करना है with half-life, decay constant and T, and if you want to link this with half-life, then the idea was this is your initial activity, right? Then इससे बस जितना time लगेगा half होने में. Make sense? So initial activity half, basically that's what you want to find out. So you can cut this half upon e power minus lambda, and time क्या होगा आपका 53.3 into 24 into 60 square.
24 to 3600.
Yeah, so हमने फिर ln आप लगा दो, so this will be ln half, and ये नीचे आया था
Divided by all this.
Yeah, so basically lambda ले लो and minus all of this, basically you just divide it, right? Determine the mass of the beryllium 7 on the leaf. Beryllium 7 on the leaf. How do you calculate the mass? Do you go with A? Do you go with A is equals to minus lambda n, where n is the number of nuclei, right?
Yeah, you could do that, huh?
So this is 39 into 10 power minus 3 because milli लिखा हुआ है. Minus lambda we know, ऊपर इनका यही दिया हुआ है, and n would be the number of nuclei. once you have n, then you know that one nucleus has 7u, मतलब इधर 7 दिया हुआ है. So n into 7u, u की value input करनी पड़ेगी from the first 2 pages. Constant से देख लेना, you get mass in kg. The leaf is covered so that no further beryllium-7 is added to the existing sample from the atmosphere. Calculate the time that must elapse before the sample activity of the sample is reduced to 2. Very simple, just input into the formula. पहले क्या था? पहले था 39. अभी हमें चाहिए 2, and you want E
minus lambda y.
Yeah. You don't need to convert because दोनों side पे कट जाएगा. But you have lambda. T is the unknown. You solve for that, and you get T. Good scene, and that's basically it for this paper.
Bye bye.